Hello dear students. In last video we have discussed the chapter of light reflection and refraction. You know that reflection means the bouncing back of light. You know, the light travels in one medium, it turns back to the same medium with the different direction. You have understand two laws of reflections. The first law is, the incident ray, reflected ray and the normal lies at the same plane. And second one, the angle of incidence. The angle of incidence is I and angle of reflection is I. Both are equal. So these two are the laws of reflections. Next we have discussed some spherical mirrors, two types of spherical mirrors, concave mirror and convex mirror. Right? Then it related to some terms, that is principal axis, center of curvature, pole, radius of curvature, etc. Next, today we are going to discuss concept of image formation by spherical mirrors. The image formation by spherical mirrors, the two types of spherical mirrors, one is concave mirror and convex mirror. So see here, I have drawn some diagrams related to concave mirror and convex mirrors. So first one, it is a concave mirror. Here it explains the reflected ray. Two rays are there. One is incident ray and reflected ray. In given diagram, the incident ray, where is the incident ray? This is the incident ray. That ray is parallel to the given principal axis. The principal axis, what is meant by principal axis? Principal axis, it is passing through center of curvature and pole point. Pole point means it is the center of the given spherical surface. We have to draw the principal axis passing through center of curvature and pole point. It is called as a straight line joining the center of curvature and pole point. Clear? The ray is parallel to principal axis. The incident ray, see, this is the incident ray, it is parallel to principal axis. After reflection will pass through the principal focus, right? See here, this is incident ray, it is parallel to principal axis. After reflection, so it falls on the surface, reflecting surface. After the reflection, it passes through principal focus. Which is the principal focus point? Principal focus point is this one. So principal focus point is in between center of curvature and pole point. The given reflected surface is passes through principal focus. It is a principal focus. That is in case of concave mirror. See the second diagram B. So here same, the incident ray is parallel to principal axis and reflected surface is, right? See here, it is a reflecting surface. In case of convex mirror, the appears to diverge from the principal focus in case of concave mirror, right? So here this is the reflecting surface, it appears to diverge from the principal focus. ಇಲ್ಲಿ ಏನು ಕಾಣಿಸ್ತಾ ಇದೆ, in the diagram of first, the reflecting surfaces passes to the principal focus. In the diagram second, the reflecting surfaces move away. It is move away from the point of principal focus. It appears to diverge from the principal focus in case of concave mirror. This is the illustrations of concave mirror and convex mirrors. Clear? See the second diagram. So in second diagram, the ray is passing through principal focus. In first diagram, the ray, which one? The incident ray is parallel to principal focus, right? Principal axis. Here the principal axis is same, it is straight line joining the center of curvature and pole point, and the incident ray is passes through. See here, this is the incident ray. That incident ray is passes through principal focus and falls on the reflecting surface, and it refracted through in same medium with a different direction, but that reflected surface is parallel to the principal axis. That reflecting surface, in the previous diagram the incident ray is parallel to the principal axis. In the second diagram, the reflecting surface is parallel to the principal axis. Then come to the diagram B. So that is diagram for convex mirror. So clear. In first diagram, a ray passing through a principal focus on a concave mirror, or a diagram, the ray, which one the ray is, the incident ray, incident ray falls on the reflecting surface, then reflecting surface is parallel to the principal axis. It is same in first diagram, incident ray is parallel to principal axis. Second diagram, the reflected ray is parallel to the principal axis. Right, principal axis. So it is the explanation. It is the image formation by spherical mirrors in concave mirror and convex mirror. Next, come to the third point. A ray, which one? The incident ray. This is the incident ray. It is passes through. In first diagram, the incident ray is parallel to the principal axis. In second diagram, the incident ray is passes through principal focus. In third diagram, the incident ray is passes through center of curvature. You know, the center of curvature means it is a center of the spherical mirror in spherical, spherical sphere in spherical mirror. Right. So it is a center of curvature that given incident ray passes through center of curvature and it reflecting back in the same medium with a different direction. It is a reflecting surface. The reflecting surface is again, after the reflecting surface, it passes to the same center of curvature. Right. So see here also, the reflecting surface is incident ray falls on the given reflecting surface and the reflected rays moves in same direction. Right. A ray passing through a center of curvature, see here, the ray passing through a center of curvature in concave mirror or directed in the center of curvature of a convex mirror. It is a convex mirror, it is a concave mirror. After reflection in both the mirrors, reflecting back along the same path in concave mirror and reflecting back in the same path of, that is in convex mirror also, that is the same ray. So it is a explanation related to first one, the incident ray is parallel to principal axis. Second one, the incident ray is passes through principal focus. Then again third one, the incident ray is passes through center of curvature. In last diagram, image formation, the incident ray, we have done the explanation. The ray is parallel to principal axis, passes through center of curvature, passes through principal focus. Now one more point, that is a pole point. That is pole point. Again, the incident ray that is obliquely to the principal axis towards the point P. The incident ray is falls on the point P, that is in reflecting surface, and it turns back in the other direction. So it passes through same point of pole point P. So the angle of incident is I, angle of reflection is R. Right. The ray incident obliquely to the principal axis towards a point P on the concave mirror. In convex mirror, the reflecting obliquely the incident and reflected ray follows the laws of reflection. Then it is making equal angle of incidence and angle of reflection. Both angle of incidence, so it explains the second law of reflection. The angle of incidence is equal to angle of reflection. Clear? So it explains the second law of reflection, that is for the when incident ray falls to the principal pole point and it is reflected back in the same medium with a different direction, but the angle of incidence and angle of reflections are the same. In convex mirror also, the reflecting surface, the incident rays falls to the point of pole point P and it reflects to the same medium with a different direction. Right, it is the same medium with a different direction. Right, the angle of incidence, this is the angle of incidence, is equal to angle of reflection. So it is the explanation for image formation by spherical mirrors in concave mirror and convex mirrors.